Hey everyone, this is lesson 5.2 from the text, expanding and factoring algebraic expressions. The goal is to use the distributive property to expand expressions and factor expressions to simplify them. So expanding and factoring, they are opposite things. So generally expanding means to multiply things together, and factoring means to break them apart into their pieces. So today we're going to talk about both. So the first, expanding expressions using the distributive property. The distributive property involves multiplying the term outside the brackets by every term inside the brackets. And if we're looking at this using the example provided, it's A times B plus C. Now that little space between the thing outside the brackets, which is our A, and the bracket just means multiply. So if we have A right next to a binomial in brackets, this B plus C, it means A times B plus C, and it will always mean that. And when we are applying our distributive property, it just means this. It means to multiply this A with the B. And when we do that, we get this A times B. And then add A multiplied by C. Okay, so we get A times B plus A times C. And that's how we deal with this multiplying terms into brackets by a term outside the brackets. So let's use our example. Example 1, it says expand 2 times r plus 8. Well, first we're going to multiply 2 by the first term, and that's this part. 2 times the first term, which is r, and it's 2 times r, which is equal to 2r. By the way, this little dot between my 2 and the r means times. It means multiply. Next, multiply 2 by the second term, so that's 2 times 8. We'll do the same thing as we did before, but with the 8. 2 times 8 is equal to 16. Now we need to combine the terms. Combine the terms. And when we do that, we get 2. I'll write out the whole thing. 2 times r plus 8 is equal to 2r plus 16. And that is a this is our expression fully expanded. So this is 2 times, in brackets, r plus 8, expanded to 2r plus 16. Next, let's try another one. So this one's a little more complex. It's got more terms, more binomials, more monomials outside the binomials, but we can break it up into its pieces. So right away we can see some pieces here of what we just did when we expanded before. So this 3 times m plus 2, that's one expansion using the distributive property we have to do. And then this one too, this 4 times 6 plus m. That's another one we have to do. So let's start with the first one. I'm going to write it to the side. So 3 times m plus 2 is equal to 3 times m plus 3 times 2, which is equal to 3m plus 6. Now let's do the other one. We'll do the other one too. 4 times 6 plus m is equal to 4 times 6 plus 4 times m. And when we do this math, we get 4 times 6 is 24 plus 4m. Now, let's write it out. We're going to write this all out together. And it's going to look something like this. I'm going to write it in green. It'll look like this. So the result of it's going to look like the result of our first set that 3 times m plus 2, which is 3m plus 6, plus the result of the second one, which is 24 plus 4m. Now we're almost done, but we're not quite done. So we've used the distributive property to expand, but now we have to combine our like terms. So in this case, our like terms are this 3m and 4m are like terms, and then 6 and 24 are like terms. So we'll put each of these together. We get, I'm going to rewrite it. We'll group the m's together. We get 3m plus 4m, and we'll group the constants together. We get plus 6 plus 24. 3m plus 4m is equal to 7m, and 6 plus 24 is equal to 30. And so our final answer is 7m plus 30. All right, let's keep going. So part 2 is factoring expressions. Factoring is the reverse of expanding. It means finding the greatest common factor of the terms and placing it outside the brackets. And our first example is to factor 6p plus 18. And there's 2 terms here. So we have our 6p term and we have our 18 term. Our steps look like this. So the first one says find the greatest common factor of the coefficients. Well, we have 2 coefficients. So 6 is a coefficient and 18 is a coefficient. And we'll find the greatest common factor of these. Let's list all of our factors of each one. So I'm going to list the factors of 6. Okay, so 6 can be broken into, 1 times 6. Okay, 1 times 6. Factors really just means 2 things that multiply to 6. So 1 times 6 and 2 times 3. I'm going to reorder this because I like to order it from smallest to largest. 1, 2, 3, 6. And this order will help us later when we're identifying the greatest common factor. Next, we'll do the same thing with 18. So we get 1 and 18, 2 and 9. What else? 3 and 6. And that's it. So we'll reorder these as well. So we get 1, 2, 3, 6, 9, and 18. Now we're looking for the greatest common factor of both of these. So we can start at the top. Let's see. We'll start at the top of the biggest one, so the 6. So here's our 6. We're going to look for a 6 in our factors of 18, and there is one. Okay, so because 6 is the biggest factor of our coefficient of 6, and it also happens to be a factor of 18, it is our greatest common factor. So we've identified the greatest common factor. Now, step 2 says this. Step 2, it says divide each term by the greatest common factor. And let's see what that looks like. So our terms look like this, 6p plus 18. But it says it wants us to divide each term by the greatest common factor. And we do it, okay, with just almost kind of like a fraction. So 6p divided by 6, and then 18 divided by 6. So by doing this, we break apart each term. And what we get, so 6p divided by 6 is just p. And 18 divided by 6 is 3. Okay, now we now rewrite the expression in factored form. So our factor was 6. And so I'm going to put our 6 out here, and then inside our brackets goes the each of our terms divided by our greatest common factor. Okay, so we get 6 times p plus 3, and that is the answer. This is how we factor this binomial 6p plus 18. I'll write it all out. So 6p plus 18 is equal to 6 times the binomial p plus 3. Let's try it one more time. To find the greatest common factor of 14 and 35, so the GCF of 14 and 35. Well, 14, okay, we do 1 and 14. We do 2 and 7. 35, let's see, so 1 and 35. What else? 1 and 35, 2, that doesn't work. 3 doesn't work. 4 doesn't work. 5 works. So 5 times 7. Okay, and that's it. So our greatest common factor we can identify right away is the 7. Okay, this is the largest number that we can divide both of these numbers by. Now let's work through it similar to the way we did before. We want to divide each term by the greatest common factor. So each term is this 14p plus 35. There's our two terms. We're going to divide these by our greatest common factor. So 14p divided by 7, 35 divided by 7. And what we get, so 14 divided by 7 is 2. We're left with 2p. And 35 divided by 7 is 5. So we're left with 5. Okay, so that's not the end, because we have to write it out all fully factored, and that will look like this. So our greatest common factor of 7, we put outside of our brackets. Inside of the brackets is 2p plus 5. And we'll write the whole thing out. So 14p plus 35 is equal to 7 times 2p plus 5. Great, and that is it.